So on the bench tonight is a Malibu low voltage landscape lighting transformer that runs landscape lights at night. 120 volts AC comes in here and 12 volts comes out. 12 volts AC comes out on these terminals down here, and there's a little circuit breaker. And my buddy Buff just brought it to me tonight, and she says it doesn't work. And apparently the Malibu company went out of business in 2014, so this is really old. She went onto YouTube and found another video from a company called Total Lighting Supply. And the guy in that took it all apart and traced the problem to a dead coin cell on the main board. But then instead of changing the coin cell, he went on to try to sell a new transformer to replace this one that he sells. And Buff didn't want to throw this in the landfill, so she brought it to me, hopefully to like change the battery if that really is the problem. At first I said, well, how can that be? You know, a transformer is just a transformer. It's passive. There's no reason it shouldn't work forever if the coils are intact in it. But it has this digital timer in it, and that seems to be the cause of the problem. If I turn the power on here and turn these lights off, you can see that, and none of the settings on this make any current come to the output terminals here. I can put the multimeter on here and I'm getting like 1 volt, so it is dead. And it looks like we also have a segment out in this display. I'm not sure we'll be able to do anything about that easily, but we'll see. Anyway, so what I'm going to do now is flip this over. It's not the circuit breaker that's causing the problem. Check that. I don't know what this connector is. It's kind of interesting. Sort of weird 2-terminal thing there. Oh, that's the output. That's for an output cable of some kind, I'll bet. Anyway, so I'm going to take these 4 screws out the back, open it up, and come back when I've done that. Okay, took the 6 screws out of the back and it opened right up. You have the transformer here, the circuit board. That's the back of the switch. This is the battery in question. This is the circuit breaker, and I think there's a little relay hiding down here. I haven't looked very closely. Now, a smart person, which I probably am not, would test the continuity of the coils in this transformer to make sure they're still okay, because if they're not, that nothing we do will help this. And it looks like this side would be easy to test because this side goes to the circuit breaker, so that must be the input side. While I've got it here, let me just put the multimeter on it here. Hang on. Let's see if we get, yeah, so at least the input, the primary coil in the transformer seems to be fine. I'll assume this is fine. I don't want to take these wire nuts. Look, here's Mr. Spider. Hello, everybody. I'm Mr. Spider. Well, put him there. Oh, God, now I've mushed him onto my tweezers. Anyway, so let's see what we can do about this battery situation here. Let's take a closer look. So we have more webs from our spider friends. But anyway, looking at the battery here, it's just wrapped in plastic, I think maybe to insulate something. I don't know. And it's standing up off the board on these pieces of metal, which are probably spot welded to the battery. So let's see if we can just cut this off of here and see what we got underneath it. In fact, I'll just do this. Oh, it's a rechargeable battery. That kind of makes sense, but even that, after more than a decade, is going to be dead. And yeah, they spot welded the little guy. So let me get the glare off of this thing a little bit. Maybe that'll help a little bit. So I'm just going to break the spot weld. Try not to get my head in the way. Let me just... We've had spot welded things on this channel before, and you can actually make a spot welder with capacitor and some batteries. There's videos on YouTube how to do that. I don't have that, so but I'm not going to solder a new battery in here either, which I could also do. I'm going to actually put a socket on this, maybe a socket on some short wires, so that next time this has to be replaced, it won't be so difficult. But let me see if I can pry this spot weld off here. Usually you kind of get under it and roll it back like a sardine can, like opening a sardine can. Get my light on here. Yeah. There we go. And see that okay, but I'm just pulling it away from the from the battery. And what I'm going to do, there we go. So there it is. We can test it for voltage here, but I'm sure it'll be not great. That's the, let me put the auto focus back on here. Well, what do you know? It says 3 volts DC. Maybe it can't do that under load, though. I don't know. But, and I assume it's supposed to be 3 volts. Yeah, 3.6. So it's a little low. But it's tired. It needs to be replaced no matter what. So I'm going to take this circuit board out. I'm going to unscrew these 4 screws and unplug this and get the board out so I can work on it easier. Like that. Let's see, I have to deal with the knob. There we go. Get Mr. Spider out of the way. We can clean that case up. Some detergent. Yeah, so there you go. And there's our display. See if I can, maybe I'll source another one of those. It doesn't look like it'd be too hard to replace. But before I do all that, before I go ordering parts, I do want to check the coils in this. So my test before was wrong. Let me put this back on continuity. So this is the secondary side coming out, the 12 volt AC. It wasn't the primary side, and one of those primary wires goes to this one, and the other one goes to one of the output terminals here. What's going on here? To there, and this is the other side. And that's good, 0.2 of an ohm. So the secondary side is good. And then the question is, what about the primary side, which I guess is going through this relay? I see there's some more components on here too. Yeah, so if we look for the other side, it would be, this wire would be one of them. And then the other wire that goes off is in here. So really, guess we'll unscrew this because I've got it all on tape and I can see what I did. Oh, well, that that poor wire nut just came to pieces. Let's see if we can get this out of here. Pull that out of there. So that's one of the primary side, and then I think the other one is this one here. If we can get this off. Okay, and let's test then from here to here. Good, 3.7 ohms, 4.4 ohms. So the transformer itself seems to be fine, which means this is worth pursuing. So let me think about this, order some parts. We'll come back in a couple of days and put it all together or fix it. Hopefully, we'll see. Well, one more thing tonight before I do that. I got curious, so I took out the 2 screws holding this other board down and opened it up. And unfortunately, this is potted, which means they filled it with a bunch of goo because they don't want you messing around in here and seeing their secret lighting transformer sauce, you know, state secret. I don't know. Anyway, this is a relay for the output, and then there's a little cap here that looks okay. So hopefully there's nothing wrong with this, because having to do anything in here with it being potted like this is going to be a pain. Well, it's the next day. Our dead bug is still here, and I have taken the important components out of the case and lashed them up here so I could play with them because I got scared about something I'll talk to you about in a minute. I've gone ahead and ordered a replacement battery from Amazon. These are rechargeable LIR 2032 batteries. And by the way, they're called 2032s because they're 20 millimeters across, 2 centimeters, and 3.2 millimeters high. That's how they get their name. And I did find out you can buy pre-made units of this with those metal leads on them that we took off of this thing and just, you know, solder that back in just the way it was. And I guess they make these for Game Boy controllers and whatnot. But in the pre-made lash-ups I saw, they weren't rechargeable batteries. So I have a rechargeable battery, and I have different kinds of holders coming as well. So what we have here is the board that was buried down there in the depths of the case. This is a AC to DC converter on the input side. So 110 volts right now is coming in on these black and white wires. It's being converted to DC by a rectifier buried in all this goop. This weather protecting goop, I guess. I'm sure I put a title on the screen when I got that wrong last night. And then these three wires here, two of these have 5 volts, and one of them is the output that makes this relay go. And when this relay fires, then 120 volts goes out on this pink wire. And I wanted to make sure that this relay was actually working. And when this is in the box, of course, this goes to the primary of the transformer, and then the 12 volts comes out the other side. So what scared me was that when I reviewed the footage from last night, this was telling the correct time, which meant this battery had enough juice in it to keep time. And I thought, well, if it could do that, then maybe the reason it's not coming on doesn't have anything to do with the battery. Maybe it's something else. So I really wanted to get a sense that this controller and switching circuit actually worked. And it looks like they do. So what I did was, this is in the off position now, and I have a multimeter clipped to the output 120 volt thing here. And if I turn this from off to on, the relay will fire, and we'll see 120 volts come out of the pinkish reddish wire there. So, and it's hard to hear the click of the relay because the switch clicks at exactly the same time, but it is clicking. So the good news is that this relay and switch are actually working just fine. So we're happy about that. So still have good confidence we'll be able to fix this thing. Oh, the other thing I was stupid about, that thing I thought was a connector for more lights on the bottom of it is actually the electric eye here, but the electric eye connects into this connector here on the main board. And I haven't looked to see what kind of microprocessor is here on the back, and I'll go ahead and take these metal tabs out. And so maybe just taking this battery out, if it was so weak it was being a dead short on something, I can't believe that, but maybe that's true, and was pulling it down, and now that it's out the thing works. But it does look like it will switch. Oh, and one other thing, the line that fires the relay, it looks like what's happening is it's held high, and this board pulls it low to fire the relay. I say that because all I had to do was touch my test probe to it and ground it a little bit and take the voltage down a little bit, and the relay started chattering. So now I want to remove these two leads from the old battery, and obviously I could have just removed this board and desoldered the whole battery thing as a unit without breaking the spot welds, which is probably the right way to do it, so lesson learned, and probably how you should do it. This and this are the two solder joints for those leads. And I have a fancy solder sucking gun I usually use, but I'm going to do it the old-fashioned way here. For those of you who are not electronics geeks and just want to fix your darn machine, maybe this will be a little easier. So this is a 700 degree fine point iron. I don't know if your little $25, I would say Radio Shack, but there isn't a Radio Shack anymore. Your cheap irons are going to be too wide and probably too cold. And this is on the ground plane. This must be the negative, so this is going to suck heat away like crazy. But the idea is to heat it up and then suck the solder into this solder braid. This is some ancient solder wick I've had like since the 80s. What else did I want to say about that? Oh, of course, you could always just heat it and yank from the other side and pull it out without any solder braid at all. But then it's hard to get the hole clean. So let's see if we can do this, get some heat into this thing. Yeah, it's taking a long time to heat up. Come on, baby. Oh, that's heating the braid really good. Let me get this going directly here. There we go now. Suck that up, you. Been a long time since I've done this. There it goes, fell out. Another trick I pull sometimes is to take some bus wire and push it through the hole after I've melted it. Let's see. Except this bus wire's too... There we go. Now see if I can get it out. Somebody... There we go. So there we go. Clean the hole out. So that's that's the low rent way to do it, and obviously I'm not very good at it anymore. Used to be. And then the other way to do it is with a fancy desoldering gun, and then that goes like this. I need to take this out of the camera view so I can get it up straight up and down. And that cleans it right out when you can get it straight up and down. So these 2 rows of 6 dual inline pins, dip pins, are for the display, and I shot a bunch of video of me using the soldering gun trying to desolder this, and I did suck some of it up, but I think my diameter of my tip was too big, so I've switched to a smaller one. I should also mention another way to desolder is with a thing like this, is usually called a solder pult. There's actually a solder pult brand, which is yellow and blue plastic, which people love. This is my old one. And so you heat the joint up with a soldering iron, and you get some vacuum in this, then you stick it down and go click, and that works a lot like my motorized gun. So let's see now if we're going to have more success with a smaller diameter tip on this thing. Oh yes, that's the trick. Yeah. Clean, clean, clean. That should be just about ready to go. I'm gonna be gentle here because we don't want to rip up the plating that goes through the holes on the board. Still have a little tension right here. There. There we are. Oh, and I lost 2 vias. Doggone it. I shouldn't have forced it. Oh well, we'll fix those. Yeah, because I was prying instead of taking my time because I was on TV and wanted to show you how cool I was. I put too much force on this and ripped these 2 through-hole plating vias out. These are metal barrels in the holes that carry conduction from one side of the board to the other. Fortunately, on this side, there's no trace coming off of either of them on this side, so I think I can get away without replacing them. There are hack ways to rework these, but it's a pain. Like, say, this one, see, has a trace coming off of it. So it's about 4 days later, I've received a box of many, many of these fine Chinese coin cell battery holders, and the good news is the spacing of these leads is pretty close to the spacing of the holes on the board, so I think we'll be able to make that work okay. I might have to trim up this little shoulder on these leads a little bit to make it sit a little lower so it's not so proud of the board, but I think that's going to work okay. And yeah, I'm pretty sure now that it was the charging circuit trying to charge a dead battery that was using all the current and killing this board. At least that's my working theory. So before I ordered a new display, I wanted to do some testing on this old one to verify for sure that the fault of this segment that wasn't lighting up was in this device itself and not in the circuitry that drives the device. And also I wanted to know if I had the polarity of it right, whether it was common cathode or common anode. That's a fancy way of saying whether the common side of it is tied to negative or positive. So what I did was I turned my power supply on to 2 volts, connected it up, and then went through and tested lit up each little segment, and sure enough, if I show this to you here, this segment here was out, but all the others were lighting up. And in fact, if you look at this schematic here, all of these things are kind of wired the same way. Essentially, for each digit, 1, 2, 3, 4, there are a common side. All the leads are tied together, and then to make it light up, you put a voltage on this one, and then this one, and then this one, and then this one, and this one. So with a common cathode device, you put a negative here, and then you go positive, 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 and that'll let you walk through each digit and make sure they all light up. Then you go to the next one, go dot, 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 next one, dot, 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 dot. So you can test it and see. And when I got here to whatever it is, 11 and 8, that segment, which is this one here, didn't light up. Interesting to note that these little decimal points, even though there's a hole in the mask for them, are not connected to anything. And when the microprocessor is displaying something, it does one after the other, after the other, after the other. And that's why in the video you can see it strobing as the microprocessor is refreshing the display. So now we knew that this was bad, this piece, and we could replace it. And I looked all over the place for a exact replacement, and it was surprisingly difficult to find, because there's all of these parameters as far as size and these pins and everything that you want to verify are correct. I'll put that up on the screen here. When you go shopping, and I looked at our big electronic retailers here in the States like DigiKey and Mauser, and some of the smaller ones like SparkFun Electronics, and there's you know, a lot of people selling a lot of different junk, and nobody had it. I mean, even DigiKey, they had like 136 versions of this display, but none of them were the right size or electrically correct. I did finally find this one, the schematic I'm using. They're all wired the same, pretty much, so you can use any schematic for any of them to figure out the pins on a... This has 12 pins in 2 rows, so this is, as I say, this is a DIP 12. 6 pins in 2 rows. And so I found this X-Lite L, I guess, is that the name of the company? I'll put it up on there, this FD4030901. There was a data sheet for this on the factory site, but I couldn't find a way to order it. I wrote their distributor, I wrote their factory, and they said contact our distributor. The distributor looked like they only wanted to sell, you know, hundreds of these things. So I wound up asking on Reddit how to find this piece, because I didn't know, and someone turned me on to TME Electronics. I guess they're a huge electronics distributor in Europe that were not on my radar at all. So they had something that was pretty close, a Lucky Light KW439-1CV-A, which according to all the specs should be very close, and that came today from Poland, no less, by DHL. It's a 96-cent part that cost $12 to send, but it really is kind of a miracle because it left Poland on Friday and it's here Monday night when I'm recording this. So let's see how close we got. I know that they said that the background color is gray, so I hope it's not too gray, but otherwise it should be a very close match. Well, that is pretty gray when you set them next to each other, but size-wise, that's pretty good. And as you can see, they both have the 12 pins, and the spacing should be very, very close if I did my work right. Yes, and it is. So that should nicely fit in these holes here. With a little luck, one of these pins is a little bent, so I can't show it to you right now. I guess that's going to go on this side, actually. So I'll get it right side up and stick it in there, and we'll solder it in. Before I do that, I'm going to test it again with my power supply to make sure it actually works the way I think it does before I solder it in and make that commitment. But with luck here, we'll have a fully working display when we're finished with this little exercise. Well, 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 I was doing my due diligence on the replacement unit here, going through all the segments, and the decimal points started coming on, like that one there. And you remember how I said this one in the original one, the colon was connected and the decimal points were not? Well, in this replacement unit, because someone didn't look at the schematic closely enough, the colon is not connected to anything, but the decimal points are all connected to this extra pin 3 here. So that's a problem, and I think that leaves me with like 4 choices. Put the original display back in. The problem with that is, of course, that it's bad to have digits and you can't tell an 8 from a 2 or you know, although there never is an 8 on this position. But anyway, so I think that's a non-starter. So we want to do want to replace the unit. So I could go two ways with this one. I could put it in as is, in which case all of the decimal points would likely flash on every second, which might be a beautiful Christmas time display, but is probably not the best. The other thing I can do is I can cut pin 3 off back there and just lose the colon and just use digits. And if I was smart, that is what I would do. And then there's the fourth option, is to contact the vendor of the part they don't sell out of China, the Light X part that I can't get here in the US, and see what it would cost to ship me one of those. So I have the email in, and we'll see what they say and decide how to go from there. And it is 6 days later, and as I say, a smart person would have cut the decimal point pin off of this one and used it as is and not had a colon in the clock, and my friend would have been happy with that, but I'm not that I'm not that smart, and I'm stubborn that way. So I went shopping heavily. I had Perplexity AI give me a list of all the electronics distributors in the United States. I went through those, couldn't find a thing. Went through tons and tons of eBay listings. A lot of those people seem to be selling the same parts from a couple of different factories. Nobody there had it. So I went back to the distributor of this piece that's only sold in China that I first found that I thought would work, the FD403901. Well, turns out I had been ignoring the fact that the pin numbers on the high side of this were backward. I was just assuming it was, you know, some crazy Chinese way of numbering things, because usually on a dip you number from pin 1 here counterclockwise all around the perimeter, and this, if you view it that way, was going 1 to 6 and then 7 to 12, was starting over up here. Well, as I got talking to the distributor, it became apparent that I was being stupid and that was wrong, and he turned me on to the 403901 sister part, the 3902, and this has the colon on pin 3 with cathode 9, and looks to be, and in fact is, an exact replacement. But again, you can't get it anywhere except in China, as far as I can tell. So I said, how much to sell me one of these things? Because, you know, it's another 90-cent part. And he said, what did he say? $35. And I said, what? I just had this one shipped DHL from Poland for, you know, $10. So I went away for a day or two, seeing if he'd move. He doesn't care because I'm such a little order. But then I had an idea. I said, well, what if I order 10 of them? Then my cost will be $4 a display. I'll take a risk and do that. And that is what I did. And I am going to use one of these and sell the rest on eBay for like 10 bucks a pop. Because if someone really needs one, they really need one. If you're watching this video and you're trying to fix yours and you need one, I'll put the eBay listing in the comments of this video. But so that's my big plan. I don't, you know, it's just 40 bucks. I don't have a huge financial stake here, but hopefully I can get this money I spent back and make a little for my time and the shipping and everything. But what we're going to do now is take this, and I have already taken this and put my power supply on it and tested it all out. It seems to be electrically just fine. I will say it seems to want to use a little more current than the old one to get the same brightness, so the LEDs are not as efficient in this one, or the I don't know, there's no internal resistance in there, so never mind. Anyway, let's solder this into place and put this thing back together finally. Okay, we're all soldered up with the display and the battery holder. No battery in there yet. Want to try it without that first. Keep it simple. And I'm back to this setup with the 120 volts coming in from the isolation transformer into here, and then hopefully when the relay clicks, it'll send 120 out the pink wire again to the multimeter. So let's turn this on and see if our clock lights up, or if those torn pads are going to mess us up or what. Here, let's see. Well, that's good, I think. Oh, let me turn the multimeter on. And it's showing no current at this point. Let's, well, that's pretty. And the colons are flashing like they should. Can you see that okay? Kind of low there. Let me maybe move that a little bit. Yeah, so I don't know what all the positions are here. Let's see if we can get this on here. Oh goody, look, time is passing. I'm not turning the shaft, it's not on there, right? Hang on a second here. Let's see. Okay, so we have 120 on. Still on. And now it's off. It's nice and bright, so that's something. Hang on a second, let me go look at the box this came in and see what the settings are to change the clock. Okay, so it seems like holding this down and this down should change the clock. There we go. Whee! See if all our segments are working. Oop. Oh, and the AM PM. Okay, I think we're good. So the display is fixed. Let's see if this will actually work with a battery in it. A bunch of these fine. I haven't opened this up. It's been here a couple of weeks now, almost a couple of weeks. Oh, I think there's like 5 of them in here, and they're all individually wrapped. Very nice. Well, we'll just put those in the battery drawer. Okay, and let's see if it still works with the battery in it, which obviously is what started this whole mess. There we go. Off. On. Okay, I would say that is fixed, and all we have to do now is assemble it back into its case. So I use closed-end crimp connectors to make the wire connections inside the box because I think they're a little more rugged than the wire nuts that were in there, even though they may make it more difficult for the next person who has to service the unit to get them off. As far as the battery is concerned, the rechargeables came in out of the package at 3.9 volts. They're supposed to be 3.5, and the one we took out was 3.0, so definitely I think it was a short, dragging the whole circuit down. And finally, in case I wasn't clear, the transformer, the top section is the secondary and the wires come out on the top, and the bottom section is the primary and the wires go in under the bottom. And if you know that, that should help you reassemble it. But here it's all finished. I cleaned up the case with a little Novus 2 plastic polish for extra credit, but everything's working fine. It keeps time when the power's off, although it does seem to gain maybe time just a little bit, but essentially, it's all working, and this is all done and ready to go back. So thanks for watching this exciting saga. Like, subscribe, and we'll see you on the next one.